In today's data structure class, we will see the heap sort from third unit, searching and sorting. And in this class, we will see what is heap sort, that is the definition of heap sort, and then the knowledge of complete binary tree is very important for constructing binary tree for this heap sort. Hence, we will see the complete binary tree. After that, we will see the three important properties for this binary heap, and then the algorithm for heap sort. After that, we will solve one problem for this heap sort. So we will see one example, and then the advantages, disadvantages, and applications of heap sort. So these are the topic we will see in our today's class. The heap sort is a tree-based data structure in which all tree nodes are in particular order based on heap properties. Okay, so the heap sort uses a tree structure, and here all the nodes should maintain some relationship throughout the tree. Okay, and this parent-child relationship should be maintained based on the heap property. Okay, here the heap data structure, the tree is complete binary tree. Okay, the tree, it should be a complete binary tree which referred as binary heap. Okay, here the heap sort maintains both array and binary tree. Okay, throughout the program we need to maintain an array as well as the binary tree. Heap sort definition: construct the heap data structure based on the given unsorted array. Okay, so this is our A, and here this is heap sort. The input to the heap sort is a set of unsorted array elements. Okay, and output will be the sorted data items. Okay, here first based on this unsorted data item, we need to construct the binary tree. Okay, so we have to construct the binary tree by using the given data items. And step 1, if only one node in the tree, then print the result. If there is only a single node, then no need to do any other thing, so we can directly print the result. Else, heapify the binary tree. Heapify means the maximum value should be reach the root value. Okay, that means the parent node value should always be greater than the child node. Okay, accordingly we need to heapify so that the maximum value that will reach the root node. So this is called as max heap. Okay, see, once the maximum value reach the root node, then replace the max heap with the last node. That means the maximum value should be replaced with the last node in the last level, that is rightmost node in the last level. Okay, and then store the last node data into array and delete the last node. Okay, this data item should be stored in the array, this place, and the node will be removed from the tree. Okay, and repeat the steps 2 to 4 until all the nodes will be removed from the tree. Okay, so these steps should be repeated continuously until all the nodes should be removed from the tree. Okay, and the stored data, that is the sorted data, is now available in the array. Okay, that means at every iteration the maximum, that is next maximum value, will be stored in the array, and finally we will get the complete sorted data items. Sorted data is available in the array now, right? Complete binary tree. Now it is important to understand what is complete binary tree, because by using the complete binary tree only we are going to do the heapifying. Okay, a complete binary tree is a binary tree in which all levels except the bottommost level are completely filled. That means all the nodes should have exactly 2 branches. Okay, except the last branch. Right. Here the last branch may or may not be completely filled. Okay, the last level may or may not be completely filled. So this is complete binary tree, but not full binary tree. So what is full binary tree? Full binary tree means every node should have 0 or 2 children. See, this is the example for complete binary tree. That is full binary tree. So full binary tree, all the nodes should have two child, two children or 0 children. So these are the leaf node. Leaf node means the node which has no children. Okay. See, all the nodes are exactly 2 children or 0 children. This is complete and full binary tree. This is complete but not full binary tree. This is incomplete binary tree, because if it is complete binary tree, the leftmost should not be empty. Okay, leftmost branch should not be empty. Okay, so this is incomplete binary tree. And now let us see the important properties of binary heap. So these three properties are very important. First one is construct the complete binary tree. Just now we have seen what is complete binary tree. So with the given unsorted data item, we need to construct the complete binary tree like this. Okay, and heaps are mainly two types. First one is max heap and second one is min heap. Max heap means we have to move the maximum data item to the root. If it is min heap, then we have to move the minimum data item to the root node. And the next one is root element. So root element is very important here, because the maximum element or minimum element should be moved to root of the tree. Okay. The first property is constructing the complete binary tree with the given data. Okay, so this is the first property. So here the tree to be constructed with the given data item. So in this array we have unsorted data item. Unsorted data item 77, 15, 91, 21, 6 and 46. So with this given data we have to construct the complete binary tree. Okay, see, first data item will be 77. So from the 77 we need to start our binary tree, and next one is 15. So the 15 should come at left side, left branch, and next one is 91. 91 should come under the right side branch, and next one is 21. So for this level is over, next level to be started here, right? So hence 21 will come under the left of 15, left branch of 15, and this is 6. So 6 obviously that should come here only, and then 46. So 46 is here. Okay, see, in this way we have to construct the complete binary tree with the given unsorted data items. Here we have to mention the index of nodes children. So the index starts from 0. So this is 0, 1, 2, 3, 4, 5. If the values are here, then this is 6. If the values are here, then this is 7, 8 will come here. Okay, it will go on like this. And the index of parent is I. For example, the parent index is I. And the left child index should be index of 2i plus 1. Okay, for example, this is 1. 2i plus 1 means 2 into 1 plus 1. Okay, which is equal to 3. So left child will be 3. Index is 3. And what about the index of right child? This is 2i plus 2. Okay, so the index is 1. 2 into 1 plus 2, which is equal to 4, right? So this is the right side child of this parent. Okay, similarly, the child index is I. For example, the child index is 3. The child index is 3. Its parent can be found the index of floor of I minus 1 divided by 2. Okay, so this is 3. 3 minus 1 which is equal to 2. 2 by 2 equal to 1. Okay, so parent of this child is 1. For example, let us take this one, 4. Okay, so 4 minus 1 which is equal to 3. 3 by 2 which is equal to 1.5. So 1.5 floor of 1.5 equal to 1. So the parent of this fourth index node is 1. Okay, likewise we can identify the index of parent and child. The second property is max heap or min heap. So we have two types of heap. First one is max heap. Max heap means the value of node is always greater than or equal to the value of each of its children. Okay. So for example, this is max heap. Here the node value should be, that is the parent node value should be greater than the child node. So these two are children of this particular node, right? So when compared to these two values, the parent value should be greater. And when come to here, this node has two children, right? So when compared to these two values, the parent node should be greater. Like the same here. Okay. So this is called as max heap. Max heap means the parent value should be greater than its child value or children value. Okay. Like the same min heap. Min heap means the parent value should always be less than its child values. Okay. So here this parent has two children. When compared to these two children, the parent value is lesser. Likewise here. Okay. The parent value is smaller than its child value. Here also the parent value is smaller than child value. Okay. So max case means the parent value should be greater than the children value. Min heap means the parent value should be lesser than the children value. And the third property is the root element. Okay. So the root element means after heapifying, the root should always be the maximum value. Okay, when come to min heap, the root element should always be the minimum value or the smallest value. Okay, so the heap sort algorithm takes the advantage of its property to sort an array by using heaps. Okay, so every iteration, the minimum value or the maximum value should be reached to the root node so that it will be easily uh, identify the minimum value or maximum value in the given set of values. And next, let us see the heapify method. So the first step of heap sort is converting the array, that is unsorted data element, into complete binary tree. This is the first step. And after constructing the complete binary tree, we have to call this heapify method. Okay. And in all subtrees, the binary tree are max heap themselves. Okay. And the whole tree is max heap. That means the root element should be the maximum value when compared to all the other elements. And these nodes, that is the node should have the maximum value when compared to its child node values. Okay. The first one is start from bottom of the tree. Okay. See, for heapifying, we have to start only from the last level. Okay, last level value, we need to compare these two values when compared to the parent values. And iterate through all the nodes and travel to the top. So from here, the comparison will be start towards the top. At each step, ensure that the node of all its children should be maximum value or minimum value. So based on the type. If it is max heap, then the node value should be greater. If it is min heap, then the node value should be minimum. And now transform the whole binary tree into valid max heap. Okay. Suppose If we make the min heap, then we need to simply change the condition of the parent value should be less than or equal to each of its child value. Only simply the condition should be changed. And now let us see one example for this heap sort. So sort the following number by using heap sort, right? So the given numbers are 82, 90, 10, 12, 15, 77, 55 and 23. So with this given number, the first step is we need to construct the binary tree, that is complete binary tree. Okay. So 82, 90, 10, 12, 15, 77, 55 and 23. Likewise, so from left to right, we need to construct the complete binary tree. So first step is over. And then from the tree, we need to call the heapify method. So here we have to follow max heap. Max heap means the node's value should be greater than its child value. Okay, so from the bottom we need to check. So here 23 and 12, here 12 is smaller than 23, so we need to exchange here. And when come to this level, here 10 is smaller than 77, so we need to exchange these two values. And when come to next level, here this is 90 and 82, so 90 and 82 should be exchanged. And finally we get these values. Okay, 90, 82, 77, 23, 15, 10, 55 and 12. Okay, that means the 90, which is the greatest, that is maximum value, now that reached to the root node. Okay, so these values now replaced in the given array. Okay, so 90, 82, see 90, 82, 77, 23, 15, 10, 55 and 12. See, this data structure is changed like this. After that, the maximum values should be swapped with the last value in the array. Okay, see, now 90 is placed in its right position, 12 is here. Okay, so with this value, we have to construct the binary tree now. Okay, 12, 82, 77, 23, 15, 10 and 55. Okay, so 90 is deleted from the tree. Okay, that is heap after 90 deleted. Okay, now we have to call the heapify method. So the heapify method, here 82, there is no need to change anything, but here this is 1077. So these two values should be exchanged, and then 82, 82 and 12 should be exchanged. Here this is 12, again 12 to 23 should be exchanged. So 12 should come here and 23 should come here. Okay, so like this, these two should also be exchanged. Okay, see, after heapifying this particular tree, then the data values are like this. That means the maximum value 82 is reached its root node. Okay, and the array is like this. And what we have to do, we have to remove this 82 from the list, and after removing, these are the data items to be sorted. So with this data item, we need to construct the binary tree. So 55, 23, 77, 12, 15, 10. Okay, so these values. See, then we need to call the heapify method. So the heapify method, max heap we need to follow. So the parent value should be greater than child value. Okay, so this level, no problem. When come to this level, this value should be exchanged. Okay, so 55 should come here, 77 should come here. Now we need to exchange it, that 77 to 10. Okay, 77 and 10 should be exchanged and 77 should be removed. See, once we remove the 77, then These are the data items to be heapified. Okay, and 77 will reach its right position now. Now, after deleting this 77, the numbers to be sorted are 10, that is, see, 10, 23, 55, 12 and 15, right? So now we have to apply the heapify method. Okay, see, heapify method, this level, there is no problem. But when come to here, these two values should be exchanged. Okay, so 55 should reach its right position. See, these two should be after exchanging these two things, 55 reach its root node. Okay, so exchange 55 with 15, then delete 55. So exchange 55 with 15, and we need to delete the 55. Delete 55 means 55 reach its right position. And after deleting 55, we have only these items for our binary tree, right? So 15, 23, 10 and 12. Okay, so here these two values to be exchanged. So 23 is greater than 15, right? So now 23 reach its right position. Okay, see, after exchanging, now we need to swap 23 with 12. Okay, swap 23 with 12 and delete 23. That means 23 reached its right position. Okay, and after deleting 23, now the numbers are 12, 15, 10. Okay, 12, 15, 10. Now call the heapify and these two data item to be exchanged. So 15, 12, 10 is there, and we have to swap 15 with 10 because this is the last node, right? Okay, so 15 and 10 will be exchanged and 15 will be removed from the tree. Okay, that means 15 reached its right position. And after deleting 15, now we have only two values, 10 and 12. Okay, 10 and 12. Now we apply the heapify, so 12 and 10 will be there, and we need to exchange 12 and 10, and 12 will be removed from the node. And finally we have only one, so that will be directly taken. Okay, so this is the final sorted data item: 10, 12, 15, 23, 55, 77, 82 and 90. Okay, while doing this heap sorting, we can use max heap to sort the array in ascending order and min heap to sort the arrays in descending order, right? So in this sorting technique, the array actually viewed as the complete binary tree. Okay, so this is array. The values are actually stored in the array. So the physical structure is linear array only. The logical structure is binary tree. Okay, that means the exchange of data in the tree is only happening in the array. So the data will be exchanged, that is minimum value and maximum value will be swapped, right, while calling the heapifying method. So that is actually happening inside the array, not in the tree. Okay, so the map from array element to the tree nodes, how these data items will be mapped to the tree. Okay, so the array index 0 is actually the root node. So the index starts from here only. So this is 0, 1, 2 index, and this is 3, this is 4, right? So if we exchange 3 and 1 means this value, that is, this is 1 and this is 3. These two value will get exchanged. Okay, and the uh, left child, which is equal to a of 2i. Okay, so a of 2i equal to left child and right child equal to a of 2i plus 1. Okay, and parent equal to a of floor of I by 2, which is parent node, and length of a means array. length of A equal to number of elements in the array, and the heap size A is number of nodes in the array. Okay, and heap size that must be less than or equal to array size. Okay, because every iteration the size of heap will get reduced. Okay, that is the maximum element will be always reduced at every iteration, hence the heap size should always be less than array size. I saw one excellent animation for explaining this heap sort. So these are the given data items. By using the given data items, first they have constructed the binary tree. Binary tree is first constructed. Here 8 is greater than 5, hence these two value will be exchanged. And 6 is greater than 8, right? So these two values got exchanged. Now 7 is greater than 3, hence these two got exchanged. And then 2 will come here, and next 4 is placed here. Okay, now our binary construction is completed. Okay, now this value will be rearranged in the array. Okay, one by one the data values will be given to the array. Okay, now the maximum value is 8, and 8 and the last node value will be exchanged, and 8 is removed from the array. Okay, now heapifying. Now 7 is replaced its right position, right? Heapifying. Okay, 6 is the maximum value. Those two will get exchanged, and 6 will be removed from the tree. Next heapifying. Okay, now 5 will be exchanged with 2, and 5 will be removed from the tree. And next heapifying. And 4 will be exchanged with the 1, and 4 will be removed. So maximum value will be exchanged here, this will be removed. And though it is in 2, we need to follow the same procedure. Okay, so 2 will be removed and 1 will be removed, and finally we get the proper sorted array. The time and space complexity of heap sorting. The best case time complexity is omega of n log n, and average case time complexity is theta of n log n, and worst case time complexity is order of n log n. Okay, so for the time complexity of heap sorting is log n log n. Okay, and the space complexity is order of 1, because the heap sort is not required any additional space for sorting the elements. Next, let us see the advantages and disadvantages of heap sort. First one is advantages. So this algorithm provides optimized performance, efficiency and accuracy. Okay, and it requires no extra memory spaces, that is it requires very minimum memory space when compared to merge sort and quick sort. Okay, when come to disadvantage, it is very much suitable for only simple data item. Simple data item. When come to very highly complex data item, it is considered as unstable, expensive and not very efficient. Okay, so this algorithm will suits for only simple data items. Applications of heap sort. So the heap sort is used to find the smallest or highest, that is largest value instantly. Immediately, if we want the smallest value or largest value in a data set, we can implement the heap sort. And finding in order in the statistics. Okay, so the order which deals the priority queues in Prime's algorithm, which is also called as minimum spanning tree, that is Prime's algorithm, and the Huffman coding or data compression. In these algorithms, they are using the heap sort. And the heap sort is implemented in Dijkstra's algorithm, which finds the shortest path between the nodes. Okay, in the graph, to find the shortest path between nodes, the Dijkstra's algorithm implements the heap sort. We have seen the heap sort in today's class. Here we learned the definition of heap sort and what is complete binary tree. We have seen the three important properties of heap sort and algorithm, and we have solved two examples, and then we saw the advantages and disadvantages and applications of heap sort. In the next class, we will see another important topic from third unit. Thank you.